morning students. Today we are going to discuss a case study on effective utilization of waste heat recovery in a boiler. This is a case study again. So how the heat is recovered in a boiler? Okay. So first question what is telling is, as this is a case study, we will go with an DT based case study. Okay. What is the first stage here? Empathy is our first stage. Okay. So for my first question is, here the combustion of the fuel takes place. Okay. So the heat generated by the combustion is 100% utilized or not? What is the purpose of this boiler? To convert water into steam. My question is, this heat which is produced by this combustion is 100% is utilized here or not? This is my question. Can you understand? Yes or no? No. How much percent? By assumption can you tell? Some 70 or 60% it is utilized here. What about the remaining 30%? It is lost. So this is the our empathy part. So what is the empathy part is, here we are losing more amount of heat energy is lost. So where this impact takes place? Because of this, fuel is, the cost of the fuel is wasted. Okay, and the working cost is also wasted. So the wastage of this heat reflects in this fuel cost, working cost, time, maintenance, everything it affects directly. So this is our empathy. How to overcome this? What we have to do? We have to give insulation. Okay, that is one example. Okay, how to reuse this heat effectively? This is our defined statement. How to reuse this? How to effectively reuse this heat without wasting? You told that here some 65% utilized, 35% of heat is going outside. It is the 35% of heat is wasted. How to reuse this 35%? This is our question.
Recirculating.
So you are recirculating the heat. So is it possible to recirculate the heat? Okay, it's one idea. Any other ideas?
Secondary supply.
Secondary supply. Okay. Okay, I have suggested many ideas. Very good. So I will tell you how this waste heat is recovered and reused. Okay. So here what happens is, our process completed here. Okay. So water is converted into steam. So that steam may be dry steam or superheated. Okay. So whenever the steam is heated, it becomes superheated steam. Okay. So if more amount of heat is given, more amount of heat is added, so it is directly reflected to work done. Because here, what is our purpose is to run the prime mover. If the temperature of the superheated steam from 200 degree to 400 degree, then output will be more. Suppose the superheated temperature is around 700 degrees Celsius, then we can get more amount of output. So here we want to superheat the steam. So after completion, the wasted heat in the fluid gases is initially used in the superheater. You told that 25% of the heat is wasted. So first initially this superheater absorbs the heat. It traps some amount of the heat which is going outside as a waste, so that this temperature of the superheated steam can increase. This is the first method. Second method is, this is the drum where water is supplied. Okay. In normal cases, we can directly supply the water to here, and then water is supplied here. Here water is converted into steam. But now, if we are supplying water directly to this drum, okay, here heating takes place more time. Okay, so that what we are doing is, we are preheating the water here. Without directly supplying water here, we are circulating the water inside this boiler So this water is getting heated before going here. Can you understand now? So the waste heat which is going outside is we are reusing it to heat the water. So that what happens when initially heat the water here. So here what happens, quickly water is converted into steam, because when the heating takes place, first the heat is given to increase the temperature of water from 0 to 100 degrees Celsius, and then after 100 degrees Celsius water is converted into steam. So here what happens, the room temperature is 28 degrees Celsius. The room temperature is 28 degrees Celsius. Assume the water temperature as 28 degrees Celsius. If you are not heating here, the temperature of the water here will be 28 degrees Celsius. So the heating takes place here from 28 degrees Celsius. If you preheat the water here, so from 28 degrees Celsius we can increase to some 70 or 80 degrees Celsius with the waste heat which is going outside. So here the waste heat is going outside is heated. The water, that part is called as an economy. So now the 35% of heat which is wasted, here we are using some 15 to 20% we are using here. Again some amount of heat is wasted outside. It is going okay. So here the combustion takes place with the air. Initially air has moisture content. Okay, so we are preheating the air which is going for combustion, that is called as air preheat. So the heat which is going outside as a waste, it is used to preheat the air which is used for combustion. So that what happens, combustion takes place very effectively. Okay, so this is the methods where how we are recovering the waste heat in the boilers and reusing. Okay, now the 35% which is going outside is trapped, and then only less amount of heat is going outside as a waste. Thank you.